Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will derive a few identities in trigonometry. Before proceeding to derive the identities, let us recall the related concepts. First, let us understand positive and negative angles. Let us recall that angles are plotted with reference to the horizontal direction, which is conventionally taken as the positive x direction as shown in the figure. By convention, anti-clock angles are taken as positive and clockwise angles are taken as negative. Therefore, in the figure, angle AOX is equal to plus alpha and angle XOB is equal to minus beta. Now, x coordinate of a point is its perpendicular distance from the y-axis and the y coordinate is its perpendicular distance from the x-axis. In the figure, if xy be the coordinates of P, then OA is equal to x and OB is equal to y. It may be noted that x is positive on the right of y-axis and negative on its left. Similarly, y is positive above the x-axis and negative below it. Now let us find the distance between 2 points P and Q having coordinates x1, y1 and x2, y2 as shown in the figure. By definition, OA is equal to x1, OB is equal to x2, OC is equal to y1 and OD is equal to y2. In triangle PQR, PR is equal to x2 minus x1 and QR is equal to y2 minus y1. Therefore, distance PQ is equal to root over PR square plus QR square, which is equal to root over x2 minus x1 whole square plus y2 minus y1 whole square. If theta be the angle made by PQ with the positive x direction, then slope of PQ is m is equal to tan theta, which is equal to QR by PR, which is equal to y2 minus y1 divided by x2 minus x1. Now let us understand the relation between the coordinates of a point and the trigonometric ratios. Consider a circle of radius r having its center at the origin O as shown. Let the coordinates of P is equal to xy and angle POX is equal to theta. Therefore, we have OA is equal to x and PA is equal to y. In triangle OAP, we have sin theta is equal to AP by OP, which is equal to y by r, and cos theta is equal to OA by OP, which is equal to x by r. Therefore, tan theta is equal to sin theta by cos theta, which is equal to y by x. This gives x is equal to r cos theta and y is equal to r sin theta. Since r is always positive, x and y are positive or negative when cos theta and sin theta are positive and negative respectively. When r is equal to 1, we have x is equal to cos theta and y is equal to sin theta. We observe that when theta is equal to 0, P and A coincide at x. Therefore, x is equal to r and y is equal to 0. Therefore, sin 0 is equal to 0 by r, which is equal to 0, and cos 0 is equal to r by r, which is equal to 1. Also, sin square theta plus cos square theta is equal to y square by r square plus x square by r square is equal to r square by r square, which is equal to 1. When theta becomes negative as shown, we observe that x is equal to OA, which remains positive, but y is equal to AP becomes negative. Therefore, sin minus theta is equal to minus y by r, which is equal to minus sin theta, and cos minus theta is equal to x by r, which is equal to cos theta. Now let us understand the relation between trigonometric ratios of angles theta and 90 minus theta. In triangle ABC shown in the figure, angle ABC is equal to theta, therefore angle BAC is equal to 90 minus theta. Therefore, sin theta is equal to AC by AB, cos theta is equal to BC by AB, sin 90 minus theta is equal to BC by AB, and cos 90 minus theta is equal to AC by AB. Therefore, we have sin 90 minus theta is equal to cos theta and cos 90 minus theta is equal to sin theta. Now the quadrants. Q1 is from 0 to 90 degrees, Q2 is from 90 to 180 degrees, Q3 is from 180 to 270 degrees, and Q4 is from 270 to 360 degrees. Again, if xy be the coordinates of a point, then in Q1 both x and y are positive, in Q2 x is negative and y is positive, in Q3 both x and y are negative, and in Q4 x is positive and y is negative. Now cos theta is equal to x by r and sin theta is equal to y by r. Since r is positive, we have in Q1 both sin and cos are positive, therefore tan is also positive. In Q2 sin is positive and cos is negative, therefore tan is negative. In Q3 both sin and cos are negative, therefore tan is positive. In Q4 sin is negative and cos is positive, therefore tan is negative. Now we are in a position to derive the identities using these concepts. Consider a circle of unit radius having center at O. Consider points A, B, C and X on it such that OA is equal to OB is equal to OC is equal to OX is equal to 1. Angle AOX is equal to alpha. Angle BOA is equal to beta. And angle XOC is equal to minus beta. Therefore, we have angle BOX is equal to angle AOC is equal to alpha plus beta. Now, for point X, theta is equal to 0. Therefore, coordinates of X are cos 0, sin 0, which is equal to 1, 0. Coordinates of A is equal to cos alpha, sin alpha. Coordinates of B is equal to cos alpha plus beta, sin alpha plus beta. And coordinates of C is equal to cos minus beta, sin minus beta, which is equal to cos beta minus sin beta. Since angle BOX is equal to angle AOC, we have distance BX is equal to distance AC, which gives BX square is equal to AC square. But BX square is equal to cos alpha plus beta minus 1 whole square plus sin alpha plus beta minus 0 whole square, which is equal to cos square alpha plus beta minus 2 cos alpha plus beta plus 1 plus sin square alpha plus beta. Now cos square alpha plus beta plus sin square alpha plus beta is equal to 1. Therefore, we have bx square is equal to 2 minus 2 cos alpha plus beta. And AC square is equal to cos alpha minus cos beta whole square plus sin alpha plus sin beta whole square, which is equal to cos square alpha plus cos square beta minus 2 cos alpha cos beta plus sin square alpha plus sin square beta plus 2 sin alpha sin beta. Now cos square alpha plus sin square alpha is equal to 1 and cos square beta plus sin square beta is equal to 1. Therefore, we have AC square is equal to 2 minus 2 cos alpha cos beta plus 2 sin alpha sin beta. Now bx square is equal to AC square. Therefore, we have 2 minus 2 cos alpha plus beta is equal to 2 minus 2 into cos alpha cos beta minus sin alpha sin beta, or cos alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. Now for the second identity, we replace beta by minus beta, which gives cos alpha minus beta is equal to cos alpha cos minus beta minus sin alpha sin minus beta. Now cos minus beta is equal to cos beta and sin minus beta is equal to minus sin beta. Therefore we have cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. For the third identity, we use the relation sin theta is equal to cos 90 minus theta. Therefore, sin alpha minus beta is equal to cos 90 minus alpha minus beta, which is equal to cos 90 minus alpha plus beta, which is equal to cos 90 minus alpha cos beta minus sin 90 minus alpha sin beta. Therefore, sin alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. For the fourth identity, we replace beta by minus beta, which gives sin alpha plus beta is equal to sin alpha cos minus beta minus cos alpha sin minus beta. But cos minus beta is equal to cos beta and sin minus beta is equal to minus sin beta. Therefore, we have sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. Now, for a purpose, we replace alpha and beta with a and b and rewrite the four identities with fresh numbering. The identities for sin a plus b, sin a minus b, cos a plus b and cos a minus b are given in equations 1, 2, 3 and 4. Now, adding equations 1 and 2, we get equation 5, and subtracting equation 2 from 1, we get equation 6. Similarly, adding equations 3 and 4, we get equation 7, and subtracting equation 4 from 3, we get equation 8. Now, we rewrite the equations backwards to give equations 9, 10, 11 and 12. This set of four identities may be remembered as AB formula, which may be used to express a product of two trigonometric ratios as a sum. Now, let us put A plus B is equal to C and A minus B is equal to D. Adding, we get 2A is equal to C plus D, which implies A is equal to C plus D by 2. Subtracting, we get 2B is equal to C minus D, which implies B is equal to C minus D by 2. Putting these values of A, B, A plus B and A minus B in equations 5, 6, 7 and 8, we get equations 13, 14, 15 and 16. This set of four identities may be remembered as CD formula, which may be used to express a sum of two trigonometric ratios as a product. The CD formula together with the AB formula constitute the ABCD of trigonometry, which has many important applications both in mathematics and physics.